So as I mentioned, if this voltage is VO, then when it gets transferred to the other side, it's going to become VO over N, negative VO over N, because of the reverse polarity. And if you write KVL here, we have this relationship that you can find the voltage across the switch from that. If we look at the I of the primary side, it's gonna change like this with the slope of V1 over L. So you guys remember that if V is constant, the I is gonna change linearly with the slope of V over L, and then it's gonna be 0 for the rest of the period. Here, like I'm assuming CCM, right? So we start from a minimum current here, which is not 0. And if you look at the I of the secondary side, it's 0 for the first D times T. And then for after that, it's just gonna basically go down from a point here. And this peak depends on the I peak primary and the turns ratio. Okay, so because of the turns ratio, the current is gonna get scaled as well. So that's how we can draw different waveforms. And if you look at the flux, it's basically, it's gonna be because flux is L times I, right? Lm times I, so it's gonna be something like this. This part is from the primary side, this part is from the secondary side. So this basically shows like how energy gets stored and then gets released. Gets stored when you have the switch on and gets released when you have the switch off. This switch. Okay, so the next thing I wanted to talk about is I wanted to also mention about the advantages and disadvantages of flyback converter compared to buck boost converter, right? So one of the advantages that flyback converter has is that because of this isolation that we have, it is easily expandable so that you can have multiple outputs. So in many applications, you need different voltage levels, right? So let's say like you need to build a power supply to have like 6 volt and 9 volt. So you can do it in 2 separate converters. But what we can do, if I replace this with just like a switch symbol, if you can just add another converter here with the opposite polarity. I should have like done this. Should be the other way around. Sorry. Why is it the other way? So because we changed the polarity of this one, we also changed the polarity of this one. I'm not sure how long this has been going on, but the polarity of the diode should be in the other way because we want to have the positive polarity of the voltage on the output side. So for this one, it's going to be the other way around, and then so this way you can basically have 2 different voltage levels, because like this one has different turns ratio, right? So you can have different voltage levels on the same core. You just basically have the same core and you have different windings on it, and these are coupled. So based on that, you can generate 2 different voltage levels. This is doable, but because of the leakage in inductance, it's not very accurate. It's not optimal. So your ratio, your optimal ratio might not hold when you build this. So let's talk about some of the advantages of flyback converter. Maybe I should do it once with the perfect. Okay, so one of the advantages that you can see is that, although we need to have a coupled inductor, but we don't need to have a filter a filter for the output side, and inductive filter as we had in buck converter or boost converter, or here like buck boost converter. So we just have this isolation transformer. It can do both a step up or a step down. Similar to buck boost. Isolation. So because of the isolation, it can get connected to, for example, to a DC grid or like higher voltages. So you can have, for example, 120 volt to 5 volt. The disadvantage mainly is basically the same disadvantage as we have for other switch mode power supply: ripples in voltage and current, noise, EMI. Right? We can have multiple outputs. It's economical. Because like the number of elements you need is not that much, and you see that like if you expand this with multiple outputs, you don't need a separate inductor for each one. Just like one big coupled inductor is going to be good enough. Okay, so these are some of the advantages of the flyback converter. Also, it's more stable than buck boost converter. It's more stable than the boost converter as well. So if you derive the transfer function of this one and linearize it, and you just see that it's going to be stable for different values of duty cycle. Okay, so then let's talk about the next topic that I wanted to mention. It is wanted to also mention the discontinuous conduction mode. If I can find it somewhere here. Yes. Okay, so let me make sure that so these are the disadvantages. These are the advantages. Yeah, I covered all the disadvantages. Very popular. If once I open my laptop